Hello, so I've been having a look at the different types of problems out there and where the direction's going, and this is probably not totally brand new news to everybody, but what is brand new news to people is the types of support that there may be for different platforms compared to the standards. For example, we have Vulkan and OpenGL, which is used to do the rendering on the head-mounted displays. And then we also have OpenXR, which is a standard so that each one of the VR devices could support. So you develop once and deploy many times. Now, Vulkan, I will provide a list of links as part of this journey of this video that you see here. Cronus 2016, we talk about the CPU versus the GPU instead. So Vulkan is cross-platform, and as it says here, it's a successor to OpenGL. So some tests for Vulkan is actually 10 to 15% faster than OpenGL, and OpenGL may not be cross-platform, but Vulkan is. Now, as it says here, lower CPU, which means you've got the 20%, you've got the extensions that the headset providers or the engines can plug into. We have the ability to do multi-threading, and also we have anti-aliasing, and a lot of this stuff you don't have to do because normally it's wrapped up. When you're using, you can use the API directly for Vulkan, but most of the time you will be doing this via an engine, and it has its own foveation API. So I have tried some of this foveation, and obviously we can set the different levels of quality for rendering, but sometimes you don't get the effect that you want depending on the detail and quality that you need.
Is the ability to have fine-grained control.
So as it says, you have control, but the problem is about fixed foveated rendering is that you can have the center of it high quality, the items, the section surrounding it lower quality, and the section surrounding that even lower quality. Now the problem is in the current set of eyesights, if they're not pro, for example, is that they don't actually track where the eye is. So as you look to the left, you can see the low quality because there's no eye tracking. When there is eye tracking and it's hooked up, when you look to the left, you're still looking at the higher quality because on the foveated rendering, you can save, for example, 60% worth of graphics work by using that level of foveation if you're able to track the eye, but most of them cannot at this time. So we'll skip this because this is mostly engine stuff. But as we look onto OpenXR, we have a standard. So currently when you develop something on Unity or Unreal, if you're not developing to OpenXR, then you may not be able to deploy to another type of device. You might develop something for the Oculus Quest, and then it won't work for, let's say, Windows mixed reality immersive environments like the HoloLens or the Vive. So that's bad news, and that's why OpenXR is a good idea. And they talk about the open specification from Kronos. Kronos are the same people that did this Vulkan side. So if we look at the OpenXR, we have a number of things. We have core things that everybody has to support. That means there's always going to be a delay in some way. If an environment, if a both the headset and also the game engine supports the OpenXR core, then that's great. The problem comes down to when we're looking at the extensions. There can be a delay from when extensions are added. So if we have a look at StreamVR, that supports OpenXR. But there's three actual things that are going on. So let me point this out. So in this diagram you see lots of devices, and then you've got the interface, oh you do see it here, and then you have the game engine itself. The game engine could be the Unity generally, or Unreal. And then on WebXR, this would be supported by the browser itself, whether it would be Chrome, Firefox, etc. But the main interest is in the game engine side. Now, as we were saying, that we have the core aspects where all of them have to support. These are all the different types of objects that support the core. Some of them will support different types of extensions. For example, the HoloLens would support the spatial aspects, and maybe the Oculus Quest doesn't at the moment. They're just introducing the pass-through type effects at this time. On the Unity Unreal, this is where it gets interesting, because the standards do not change as such that often. So in the case of, let's say, Oculus, that gets updated, let's say, every month, and that would support some of the core plus some extensions. But then we have the game engine, and that has a major version every X months. So normally every quarter, every 3 months or so. And that would support maybe some of the core and some of the extensions. But then it would have to make sure that this Oculus, we've got the game engine, but they would also have to have one thing in the middle, which is support for the device. So this is the device itself. This is a plugin for the game engine. And the problem comes is that each one of these means that there's a delay in some sort, in some way, or maybe a different types of interpretation of how this fits together. So let's say OpenXR and game engine. So these are the things that's pretty your, and then your code. So what we have, your code talks to the game engine. It sees if OpenXR is supported. Obviously your code is representing the OpenXR side. We've got the plugin within the game engine for that device, for the Oculus, and then we have the actual software on the Oculus itself. Now each one of these can change. This is a set standard, but the implementation can obviously change. So we're expecting some variation in some ways. So you may have a case where Oculus Quest would work, and you may have Vive that doesn't work, or doesn't work as well, or is a bit slower, or whatever the case. Not unless that's somehow controlled by OpenXR. Now, if we look at the current state of this, we have OpenXR, what supports it. Here's the roadmap, but then we have to say what the support is. OpenXR, Microsoft current recommendation for HoloLens 2 is Unity 2020.3. That would be, what is it, the 7th month. Long-term support for the OpenXR. This doesn't say about the other, obviously, the other types of devices. But OpenXR is supported for the Unreal side. So let's have a look. So Unity, so from the 6 months, so to 2020.2, so that's June. From halfway through 2020, it supported mixed HoloLens and HoloLens 2. DirectX 11 is talking about the current types of API. DirectX 12 is more ray tracing and not really supported on most things. And we can see that Unity tends to have things living in beta for a long time. But we can see we have its own code where it checks a number of things and provides a number of troubleshooting. And this is another very interesting thing. If we're doing VR, the interaction toolkit is still in beta as well, and how to upgrade it. So my feeling is that Unity is a little bit behind compared to Unreal, given that Unreal is not in beta for these types of things, not unless Unity just has a different policy for how long they have something in beta. Then when we have a look in Unreal 426, which is the current version as of August, we have mixed reality, which is generally anything that is white labeled version of HoloLens. And then we have Oculus and Stream VR. So as part of this is that not only one of the problems that we've seen before, we had your code. So we've got a number of problems here. We have Oculus device support for XR, whether there's a plugin for OpenXR, OpenXR existing on the game engine, and then we have your code. But then we also have starter kits. So normally your code may work off a starter kit, and this starter kit would be, let's say, more restricted in some way or not, depending on what you're doing. So if you're looking at Unity, you can sometimes get a package that has everything to do with VR within it, but then you'll have to enable OpenXR, for example. But on the Unreal side, as on 5, this is always a trade-off. That Unreal 5 is in early access now to be released early next year, 2022. It will support OpenXR and have all the toggles already enabled. The downside is it will be a bit buggy, and this is one of the problems of generally early adoption. But when you times it by the amount of things to get established, that means that the developer ends up troubleshooting at these different layers of trying to configure something on the game engine or the starter kit, or having to wait for this to update, for the plugin to update that's part of the game engine, OpenXR, the starter kit, and also your code might be doing something wrong as well. So I just wanted to talk about where we are in terms of the XR type approach, and the OpenXR, as it says, AR and VR devices. So as it says here, we've got two things going on here that explains it in maybe a bit more detail, and it gets a bit more complex because if we have a look on here, imagine your code's down here. Actually, it's more up here, it's more at the top. So provider implementations of whatever plugin there are. So AR Core and AR Kit. AR Core being Android, AR Kit being iOS. Oculus XR. So these two things are the mobile side. This is the Oculus Quest. This is the Windows Media plugin. This is Magic Leap. And then we have the Oculus XR plugin that talks directly to objects itself instead of this OpenXR. So obviously if you're developing for this and you switch to this one over here, you could experience problems, and other third-party plugins, and the Unity XR SDK which includes all these bunches of things. Then finally, what the game engine adds on top. So these things on beta, and then the AR foundation, which is augmented reality and the ability to interact with things, and then moving up to either the VR app, either the AR app. You can see you have to use both these things, or the VR app. But on the Unreal side, I'm not sure if I've got it here, we might see a different story. So import XR, and I noticed this movement in the last couple of versions where Unreal's had this support for the input mapping, where you're able to give it a label and then a number of keys. So when you actually press this, one of these things that are defined here, it triggers a name that you're binding to by what it's called, and then you write some sort of function that binds with it in Unreal. Now, in Unity, they have only just started introducing the ability to switch between the two different modes. They have the old input system, which isn't this, OpenXR compatible, and then we have the Unreal type of integration. So as far as everything's concerned, is that Unreal for input and a lot of the OpenXR, etc., they are ahead, but in terms of Unity, Unity has a lot bigger code, a lot more developers in the first place, and slightly behind on the development, but it's more likely to find some documentation sometimes compared to Unreal. So I wanted to just talk about how this fits together. So in summary, we're looking for OpenXR and Vulkan. That's where we want to go. But if we implement something on OpenXR and Vulkan, we may not get the kind of experience that we want to right now, because not everything may be supported. But we should develop for the future as well. And another two interesting things is that in, for example, Unreal and Unity, we have two types of quality, and they're done in slightly different ways. You have a universal a URP type provider for Unity, so we have like a VR pipeline, and then we have, which is low quality mobile, and then we have the HDRP type quality, which is for desktop. There's no easy way to work between them, so you can't have one and then have the other. There's no easy way to switch between these two different solutions without compiling separately about these capabilities or detecting them. Unreal, on the other hand, has a slightly different approach where you do it based on capability, which is more of the correct way of doing it to avoid development, but there's a lot more having to investigate a deeper learning curve to get to that point. Everything would just slow down. Unreal makes the assumption you know what you're doing, and so you know what every single setting is, and when you change something, you're prepared to pay the price as such, like it would just slow down. Whereas in the Unity world, if ever it was, you've got the low quality pipeline that has all the abilities to render on the VR side, you can still slow it down, but it's less likely to make a mistake because these are two separate profiles. So, and the same thing comes down to the rendering as well, where we are in Unreal, we are compiling all the time all these different assets of however way you've defined the materials, etc. In Unity, when you are working within a certain platform, let's say you're the HDRP, you need all your assets in a certain quality to begin with. So you can have one or the other as such. and that's how they kind of define it. So it's a lot more work on the Unreal side, but you would only have to develop it once if you know what you're doing. But you might get most of the way just on using the simple abilities of Unity, for example. So just something to talking about Vulkan and OpenGL, OpenXR, not OpenXR, Unity versus Unreal. So thanks